Today we are going to talk about how to solve exponential equations and logarithmic equations. An exponential equation is when there is a variable in the exponent. The first thing you do is isolate the base and the exponent. So in this problem here, 45 times 2/3 raised to the x fifths minus 7 equals -2. To isolate the variable, the base and the variable, we will add 7 on both sides. So that'll be left with 45 2/3 raised to the x fifths equals -2 plus 7 is 5. And then to isolate the variable, we divide both sides of the equation by 45. So then we'd be left with 2/3 raised to the x fifths equals 5 divided by 45 reduces to 1/9. And now that the base and its exponent is by itself, is isolated, we change it to logarithmic form. So logarithmic form would be log of the base in this case is 2/3, of the value, so 1/9, equals the exponent, x divided by 5. When we put that into our calculator to evaluate, we get about 5.419 equals x over 5. So then to get x by itself, we multiply both sides of the equation by 5 since it's being divided by 5. So that means our final answer would be x equals 27.095. In our second example, we have a variable in the exponent, but in this case, we have a base of e. So in this case, we're going to use natural logarithms to solve, but we do need to isolate the variable just like we did in the last one. So the very first thing we need to do is subtract 17 on both sides of the equation. And that means you're left with -48 e to the 0.7x minus 1 equals 11 minus 7 is -6. Then to isolate the variable, we should divide both sides of the equation by -48. And so I'm left with e to the 0.7x minus 1 equals -6 divided by -48 reduces to 1/8. So now to eliminate the e value, the base of e, we take the natural log of both sides of the equation. And the reason I can do that is because a natural log has a base of e. So the rule is that when the bases are the same, that you're left with the exponent. So in this case, on the left-hand side, we're left with 0.7x minus 1 equals ln of 1/8. So to isolate x, we would add 1 on both sides of the equation. So that means I'm left with 0.7x equals the natural log of 1/8 plus 1. And so then all we have to do now is divide both sides of the equation by 0.7 to get x by itself. So then if we put all of that in our calculator, ln, the natural log of 1/8 plus 1, all divided by 0.7, we should get x equals -1.54. Now to solve for logarithmic equations, the first thing you do is condense the logarithmic expression into a single logarithm. So here we have the natural log of x plus 4 minus the natural log of 5. So we want to condense it using the quotient rule. We're using the quotient rule because the two logarithms are subtracting. So the rule states when you have two logarithms that are being subtracted, you can condense them by dividing their terms. So we have x plus 4 all divided by 5 equals 3. Then a natural log has a base of e, so now we can change it to exponential form. base raised to the exponent equals the value. So we have e raised to the third power equals x plus 4, all divided by 5. So I can isolate x by first multiplying both sides of the equation by 5. And so that means I'm left with 5e to the third power equals x plus 4. And then finally, I can just subtract 4 on both sides of the equation to isolate my x. So I have 5e raised to the third power minus 4 equals x. And so now if I put that in the calculator, you should get x equals 268.991. And then finally, for our last problem, to condense these two logarithms, because they're being added, we can condense it into a single logarithm by by multiplying their terms. So 3x times 7 is 21x. Then I can change it to exponential form. Our base is 2, which means it gets raised to the fourth power, and then equals 21x. So I have 2 raised to the fourth power equals 21x. 2 to the fourth power is 16. And then to get x by itself, we divide both sides of the equation by 21. So therefore, x equals 16 divided by 21. And that's how you solve logarithmic and exponential equations.